Question number 13. An object shaped as a hemisphere rests with its flat surface on a table. The object has radius r and density rho. Volume of a sphere is so much. What average pressure does the object exert on the table? Pressure. What is pressure given by? Pressure equal to force per unit area. Now what is the force acting on the table? The mass of the sphere, right? Mass of the sphere divided by 2 divided by area. Why did I divide by 2? This is nothing but the half of the mass of the full sphere. It's hemisphere, right? So I did like this over here. Now, how do I write mass as? Mass can be written as density into volume. What is density? Density is density only. It's already given here. Where is it? Density is given here. But volume, okay, volume is nothing but 4 by 3 pi r cube. It's nothing but the volume. So I can divide this by 2 to get the area of this one, mass of this one, weight of this or force acting on it. And what is area? Area is nothing but pi r square. Now divide one by the other, substitute it. So therefore, pressure is equal to rho into 4 by 3 pi r cube divided by pi r square. So square, cube goes away, pi goes away. Did I miss anything? And there's a 2 here. I'm sorry. There's a 2 here. Where did the 2 come from? It's here, right? So 2 1s are, 2 2s are. So this should now be equal to 2 by 3 rho r. Did I miss anything else? I think there is a g here. G here. Okay, m into g, right? So this g into g over here. 2 by 3 rho rg. 2 by 3 rho rg is answer D. Okay. Is there a g? Yes, g, yes.